For this quest, I figured the first thing I should do is decide what the base stats that I needed for the machine. Most important thing are the travel, the weight, spindle RPM, input voltage for what I have available, and be able to be moved by myself. I quickly determined that there was no off-the-shelf milling machine out there that would give me exactly all of these stats. That's when I decided to just look and see what there was, come up with something that was very close, and ultimately I ended up going with the Precision Matthews 728 VT. It got as close as I could get for the travel, spindle RPM at over 4,000, and it was a little heavier than any of the other machines I was looking at. Here are a couple of different views with the machine currently on the pallet as it came from the shipper. Another important thing about the 728 VT is that Precision Matthews has a ball screw and CNC conversion kit that you can also get. This gives you all the components that you'll need for ball screws, the bearing mounts, and anything else that is from the mechanical side required to make this a CNC machine. Here's the ball screw and CNC kit, all in its package. Again, it came with everything I needed to make it mechanically work as a CNC machine. And that checks two things off our list. To control the CNC, I ended up going with Mach 3 as the software, going through a USB-C dock, connected to the Ethernet smooth stepper, which was directly connected to the servo motors. Here you can see my poor attempt to make standoffs for the offset between the C25 breakout board and the Ethernet smooth stepper board, using plastic and then metal inserts. This would be a perfect problem for a 3D printer to solve. However, at the time I didn't have one, so I did what any reasonable machinist would do: machined it out of billet plastic. And here it is, attached to the subplate for the control box. Movement, I went with the Technic ClearPath SD SK series. SD stands for Step Direction, SK stands for Stepper Killer. They come in both NEMA 23 and NEMA 34 frame sizes, using NEMA 23 on my X and Y, and NEMA 34 on my Z axis. To get all of this, I ended up using a junction box from Kilipis, whatever. I chose it because it was a sealed box. That was until I cut two big holes in the bottom of it. One for intake, one for exhaust, with a fan so they get air circulating throughout the machine. It also has a subplate that makes it easy so that I can mount all the components to. That way I can mount it inside the box with ease. If you ever end up designing a CNC machine, I highly recommend you get the largest junction box that you can afford. And by afford, I don't just mean by money, mostly mean by size. When looking for boxes, if you look at the stats on whatever website you're looking at, it always seems like it's going to be way bigger than it needs to be. And in reality, once you start putting things in there, it ends up eating up the space really fast. I also cut holes in the back and used flange type connectors to seal outside from inside while still being able to connect power and control cables. Well, thanks for... Wait, I can't leave you there. You gotta watch some CNC footage before you leave.